Balikan po natin yung expression ni internal energy change. So, di ba? It's du equals dq plus dw, but dw is minus p external dv. Ngayon, napatunayan natin, we have derived this expression na yung change in internal energy is cv dt. And kapag hindi naman perfect gas, so generalize natin, okay, for any gas, plus yung second term na partial derivative of u with respect to v at constant t dv. Now, let's divide this equation by temperature, or T. At it's not T, it should be dt rather, by differential T at constant pressure. Okay? So, umpisahan natin dito sa dq, so magiging dq over dt at constant pressure. Ito naman magiging minus P. Let's say the P external is just your P, and let's say it's constant. Well, it's constant because we assume here that it's constant. So, nandyan lang siya. And then yung dV part niya, magiging dV over dt. Kasi we are dividing by dt. At constant pressure. Okay, and then we have here cv dt divided by dt will just become cv plus yung last term natin. So, mangyayari dyan is magiging partial derivative of u with respect to v at constant t, and then yung dv magiging partial of v with respect to temperature at constant pressure. Kasi nga, we are dividing by dt at constant pressure. Okay? In fact, I'd like to use partial derivative dito. So, instead of dv, gawin ko siyang partial of v. And instead of dt, I'll use partial of t. Okay? Now, yung dq dt at constant p, isa rin siyang expression natin for cp. Tama ba? Okay. And then you have cv in this side of the equation. So if you put it on the other side of the equation, minus cv na siya. Okay. So the others, let's collect them at the right-hand side of the equation. So ano mangyayari? Magiging equal siya sa, if you notice, ang kanilang common factor ay partial derivative of v with respect to t at constant p. Tama? That's their common factor. Okay? So, multiplied by p, kasi naging positive, kanina negative siya, plus partial of u with respect to v at constant t. Okay? Which is this one. So, I just simplified the equation. Ganun lang yon. So, let's continue. Paano kapag perfect gas ang pinag-uusapan na natin? Ideal gas. So, kung ganon, ang mangyayari is, remember, this term here will be equal to 0. So, makakancel siya. Tandaan nyo yun, di ba? Nakita natin yan kanina or in the previous lecture, video, na partial of u with respect to v at constant t is 0 for a perfect gas. So, anong matitira sa expression natin? Magiging Cp minus Cv equals, mayroon kang P multiplied by the partial derivative of V with respect to T at constant P. Okay. Now, again, pinag-uusapan natin is ideal gas or perfect gas. And the equation of state that governs the ideal gas is yung PV equals nRT. So, if I want to calculate the volume, magiging nRT over P yan. Okay? Now, what if I'd like to determine the partial derivative of V with respect to T at constant P? Bakit ko gagawin to? Ito yun eh. Yan yun. Gusto nating maghanap ng expression for that. Eh, syempre, gagamitin natin yung ideal gas equation because we're dealing with a perfect gas. So, if you do this derivative here, okay, use this equation right here. So, paano yan? Derivative of volume with respect to temperature at constant pressure. N is constant, R is constant. Constant daw si pressure. So, anong matitira? Yung temperature, right? Kasi yan yung variable natin. Derivative of volume with respect to temperature at constant pressure will just be this expression. Okay? Rule of differentiation. So, NR over P na lang. So, tuloy natin dito, Cp minus Cv for perfect gases is equal to P times yung ang nahanap nating expression na NR over P. So, ang mangyayaring next is that magka-cancel lang yung ating P. So, ang matitira sa ating equation is Cp minus Cv is equal to N times R, which is our gas constant. So, kapag dinivide mo to by the number of moles, magiging Cp M yan. M here means molar. So, molar heat capacity. Molar constant pressure heat capacity minus molar constant volume heat capacity will be equal to R. And this is now the relationship between Cp and Cv. So, just get the difference between Cp and Cv. Yan yung value ng gas constant.